I'm Dr. Om Prakash, and today we are going to discuss about Way ANOVA and how manually calculate it. There are certain statistics associated with Way ANOVA. Uh, the statistics associated with Way ANOVA similar to the statistics associated with one Way ANOVA. There is a statistic, a null hypothesis that the category means are equal in population, and it is tested by an FS statistics based on the ratio of a square x1 and x and square related to error. Mean square is the sum of squares divided by appropriate degrees of freedom. Sum of squares, also denoted as x, is the variation in y related to variation in the means of categories of x1 and x. This represents variation in the categories of x1 and x2, or the portion of sum of squares y related to factor x1 and x2. It is also denoted by SST, that is sum of squares for 3. SST within sum of squares, also referred to as SS error, is the variation y due to variation within the categories of x1 and x2. This variation is not accounted for by x1 and x2. It is also denoted by SS, that is sum of squares for error. Then this is extra sum of squares case of two-way ANOVA. It's called SS interaction or sum of squares for interaction. This is the combined sum of squares of two factors x1 and x or interaction of two factors. This is why this is the total variation in y, also denoted by TSS, total sum of squares. What we need in two-way ANOVA table? We need 5 things. First is source for sum of squares, degree of freedom, mean square, f static. Suppose we have factor 1, then source of factor between variation will be factor 1. Its degree of freedom will be calculated, j minus, where j is the number of categories of factor 1. Similarly for factor 2, if the number of categories of factor 2 is k, then we subtract 1 from k and the degree of freedom is k minus 1. For the interaction term, the degree of freedom will be simply the degree of freedom for factor 1 and degree of freedom for factor 2, both are multiplied. For degree of freedom within, we subtract the number of categories of factor 1 into number of categories for factor 2 from the total number of samples. Degree of freedom for total sample equal to total number of total sample minus 1 is here in minus 1. Then we calculate MS square. A square is nothing but sum of squares for factor 1 divided by degree of freedom for factor 1. Sum of squares for factor 2, degree of freedom for factor 2. Similarly for MS interaction term, it will be sum of square for interaction divided by degree of freedom for interaction. Similarly, MS for within will be sum of squares within divided by degree of freedom within. F the statistics calculated mean square for factor 1 divided by mean square within. For factor 2, mean square for factor 2 divided by mean square within. For interaction term, the F ratio will be mean square for interaction divided by mean square within. Let us take up an example and understand how to calculate two-way ANOVA manually. Suppose a detergent manufacturer wants to explore how a detergent having two variable varieties x and y and a particular water temperature having 3 tags, that is cold, water and hot, affect the dirt removal of laundry. The manufacturer also wants to check whether the combined effect of detergent and water temperature can affect the dirt removal. This combination, one would wash 5 loads, shall be replicated. The manufacturer records the information and so on in table 2. The numbers for the amount of dirt removed. Table here the detergent has two categories, detergent X and detergent Y, and water temperature has three categories, cold, warm, hot, and this the number entered is the amount of dirt removed by categories. For the solution, we have to identify which are the dependent variables and which are independent variables. Here the dependent variable is the amount of dirt removed and dependent variables are detergent and water temperature. Why do you do? Here two factors with multiple levels and are detergent and water temperature. Detergent has two categories and water has three categories. Steps for calculation of ANOVA manually. Firstly, calculate mean of each category for each factor and grand mean or overall. Step number 2, we calculate between variance for each factor, that is detergent and water temperature, using formula summation of n, that is equal to sample size of A, the bracket x A is the mean of group A, minus x is the grand and B square. Table number 3, this represents the means and between variance we have calculated from our sample. Here the group mean is 9.367, which is obtained by adding the values of all samples. Here we have 30 samples, so we have added all values of all samples and divided it by 30, so the value is 9.367, our gram. Then we have to calculate the mean for each category. Here detergent has two categories and water temperature has three categories. We will calculate mean for detergent X and for detergent Y. Similarly, we calculate mean for cold water, mean for warm water, mean for hot water, and then we finally calculated sum of the squares between detergent. So the mean of detergent X is 8.733. These are the total values. In case of detergent X, we have 15 samples and we have added all the values of the 15 samples, divided it by 15 to get the mean value. Similarly, for detergent, we have also the sample size as 15, and so we have added all the values of detergent Y, and then divided it by 50, get in value of detergent Y as 10. Then for water temperature, we have three categories. So we have calculated mean of cold water. Total number of samples in the mean cold water is 10. So the mean value is 5. Value of warm water is 10.4 and mean of hot water is 12.7. Then we calculated sum of a square. Sum of a square between. So sum of a square between detergent, sum of a square between water group, sum of squares between detergent group is, since here sample size is 15 each, so we multiply 15 to the difference of means of each group and square it. So for sum of a square between detergent is 12.040 and similarly the sum of a square between group of water temperature is 312.467. Next we calculated within sum of a square for each. Here we have 6, as we have 3 categories for water temperature and 2 categories for detergent. We multiply total number of categories of water temperature with the total number of categories of detergent. We get 3 equal to 6. We within then next calculate within sum of a square. For this, what we do is firstly calculate the mean for each category. That is, there is not category, each group. We have 6 groups. So one group is detergent X and cold water. Second group is detergent X and warm water. Third group is detergent X and hot water. And for detergent Y, another group is detergent Y and cold water. So this is total 4th group. Then we have 5th group is detergent Y and warm water, and 6th group is detergent Y and hot water. So we calculate mean for each of the group, and then we calculate the variance, that is variation or sum of squares in each group. So for group cold water and detergent X, the sum of square is 2. For warm water and detergent X, the SS within is 32.8, and for hot water and detergent X, the sum of square within is 3.2. For group detergent Y and cold water, the sum of square within is 4. For detergent Y and warm water, the sum of square within is 6, and similarly SS within for detergent Y and hot water is 6. So total within sum of square is equal to 140. Now calculate total sum of square by subtracting grand mean from each sample and squaring them and finally summing the value. Here we calculated the total SS. Total SS is calculated by subtracting grand mean. We have already calculated grand mean as 9.367. So we subtract the grand mean from each sample and square it, and is sum of the square. Here, for example, here in this category, 9.367 is subtracted from 4 and is square by 2. The square value is 28.805. So after adding all the value, we get the total SS as 498.967. Now we calculated sum of the square for interaction by using the formula. In sum of the square for interaction is obtained as SS total minus SS factor 1 minus SS factor 2 minus SS within. Here the total sum of the square we have already calculated is 498.967, and sum of the square between group for detergent is 12.040, and sum of the square between group water temperature is 312.467, and total within variance or sum of the square within is 114. After subtracting all three values, that is the detergent between value, water temperature between value, and total within or SSE from total SS, we get 3.460 as interaction value. Then we calculate the degree of freedom for between interaction within and total sum of a square by using the formula. Here degree of freedom for factor 1 is equal to total number of factors minus 1. Total number of factors minus 1. Degree of freedom factor 2 is equal to total number of categories minus 1. And for degree of freedom for interaction is we multiply both terms, that is degree of freedom for factor 1 and degree of freedom for factor 2, and then degree of freedom within equal to n minus j. J is the total number of categories of factor 1 and k is the total number of categories for factor 2. Total degree of freedom is calculated as total sample size minus 1. We have the table number 7, the degree of freedom for different sources. Degree of freedom for detergent between equal to 1 and water temperature is also is 2. For the detergent we have two categories, that is equal to detergent X and detergent Y. So we subtract minus 1, so we obtain degree of freedom as 1. For water temperature between total number of categories 3, we subtract 1, so get degree of freedom as 2. For interaction term, this is a degree of freedom for detergent into degree of freedom for water temperature 2 to 1 equal to. Within we have total number of sample is equal to 30, and since we have three categories for water temperature and categories for detergent, so we subtract 30 minus into that is equal to 24. Here total number of sample is 30, so total degree of freedom for total is equal to total 30 on 29. Finance in the word table. We have sources, sum of experts, freedom, expert, statistics, and F value. Sum of experts between detergent is 12.04. Here the degree of freedom is 1. So MS equal to SS divided by degree of freedom is equal to 12.33. Sorry, for water temperature, we have a MS equal to 12.1 divided by 2 is equal to 1.2. For interaction, we divide of expert for interaction by their degree of freedom and is 60.47 divided by 2 equal to 30.2. So, and for bidding, we have sum of S square equal to 100 and degree of freedom 25 divide 140 by 24 get 4.150. Now we get calculate F statistics. F statistics calculated M square for detergent divided by in square bidding and 12.063 divided by 4.150 and the value is 0.5 for detergent between and for water temperature between. The F statistic is 32.89. Study for fraction, the F statistic is 0.5. We calculated, we obtained the F critical values from the F distribution table by putting the degree of freedom 1 as 1 and degree of freedom 2 as 24 and the value is 4.20. Study for water temperature, F critical value is 0.40 and fraction term is also 3.403. Detergent F statistics 0.5 and critical value 4.2. Therefore, we fail to reject null hypothesis, that is, there is no difference of the amount of dirt removed by the detergent X and detergent Y. For water temperature, since F statistics 0.89 1 greater than critical value, that is 3.43. We have enough evidence to reject null hypothesis, that is, there is a difference in the mix of types of water temperature. That means with different water temperature, the amount of dirt removed will be different. Then for the interaction, since F statistics 0.35 is greater than critical value 3.403, we have enough evidence to reject null hypothesis, that is, there is interaction effect of detergent types of water temperature on the amount of dirt removed. Thank you, dear friends.